Hello, in this video tutorial, I want to talk about the pick and place location decision that I'm given with a factory floor, which is dimension is 5 in 5 meters, with given 30 points data, which has a specific X, Y, and Z coordinates spread in the space of this factory. And I'm gonna show you that how I have chosen the right places which can outreach maximum points within a Puma robots with model 560. And to start, we shall add the robot, which is Puma models DH Puma 560. After that, we can apply the end effector, which can be this one. And the end effector for us, with the given end effector dimension would be 150 millimeters. So I will put 0.15 for this. Now you can see that Puma tool or end effector is already added. And before starting that, I'm gonna plot the Puma robot with specific angles because I want to measure what is the maximum effective range of this robot that I can calculate. And based on that, I can have a better guess to choose which locations or base points or pick and place location would be great fit for my decision for these two robots location. So I shall use or enter this command. As we can see here, and the end effector which has, in distant, we can see that how much it could outreach. So I can use also the robot teach for better specification, and it can give me the coordinates of the end effector as well, which can help me a lot to find out about the range that I'm gonna use for better guessing. So if we can observe here, you shall see that the X here maximum is that it can outreach in the specific angles and pose that I have specified, that would be 0.864. So that would be the radius of our circle as a zone that robot can access through this zone as a maximum range, effective range that it has. But since it is working like a dome shape, and when the angles toward the other axis, which can rotate and we can see it, can change, the effective range can be reduced, but the maximum one would be 0.864, which can be really effective and helpful for our decision to make the choice that which points would be a great fit for our guessing. After that, I have already tried out different locations here using this, obtaining this effective range. And I try to choose those one which could contain or include more points, as you can see here. Some of them might have even 5 points, while the other, such as circle 1 or circle 2, location 1 or location 2, could include only 4 points. But we need to consider that since we are gonna limit our robot to that the end effector must point downwards, it can also affect our pose. All the joints, ordination, or angles would be affected because of that, because the end effector must point downwards in any way that we are gonna find a solution to access all of these points. So these matters a lot. And I believe that those points which are more concentrated or more close to the center of these zones might be have a better chance to be reached or to be accessed by robot rather than those which are near the perimeter or edge of the circles or the zones, because it might lead to singularity, although I have calculated that the maximum range would be 0.864, but based on the different z coordinates it can be different, and the range or the radius based of the changing of those z coordinates can be shrinked and less than the maximum one. So we cannot rely on that, and we have to try and calculate the solution to make sure that it can be outreached. And as you can see, I've already have done that, which we will go through the commands that will be needed to find out that what points can be reached and how many of them it's possible to be outreached by choosing these points. So going back to the commands, now I shall define our my guest base location, pick and place location, which I will try the first one, Puma base, which would be 1.53 for X and 2.15 for Y. And TY means translation on X-axis or translation on Y-axis. So I have already defined that. And since we have, given the points, 30 points, I tried out to use these commands that we can have here, and which I can see you here, show you here, actually on this step file. I have already defined all the points, 30 points, and given it to um, commands for on the Linux to just define all of these easier. And also I'm going to use these commands as well. One by one, I have chosen all of these, which can be defined. For example, if I can define it, it's for T, which outreaching the points via end effector. So one of them is for translation to P1, and the other one is Rx, which is rotation for the end effector by with the angle pi. It means that my end effector must point downwards. It is the condition that we are asked for. So I added this as well. An SE3 means in 3D dimension. So I have already entered all of these before, and also define the loop for finding the solution. So if I want to, first we need to implement all of these. We will enter them, and then we will try to use the solution command using all of these T points to find out that if robot can outreach them or not, on which of these ranging from 0.1 to 0.30 can be reached by the robot using or by the base chosen by us. For example, for now, the base which is chosen is this 1.53 and for X and 2.15 for Y. So I'm just gonna paste that, knowing that. And it, as you can see, for the solution, all of these can be, observed. Out of reach means definitely it couldn't reach it. And I didn't use any specific pose, for example, right-handed or left-handed or up elbow or down elbow, but we can also add it for more accurate answer as well as if we want. But I try out to, first access all these points by, using general command. That would be easier to find out that even if these, whether if these points can be outreach, can be accessed or not. So as you can see, for example, we have already accessed 4 points. T6 means, uh, you know, the point 6 can be outreach. These are the angles of 6 joints that we have for our pose that we can use them. These are based on radians, and we can also convert them into degrees if we want. So T6, T22, T24, and T27 has been accessed by the based on the base or location that I have chosen. And the same process can be tried out for the other base locations. So as you can see, I have already defined 6 pick and place locations. And based on that, I have also specified that which points could be accessed, as you can see. And my priority would be 1 and 2. And one of the reason that I chose 1 and 2, not 3 and 2, even if 3 could outreach 4, is the points are more close to the center, which robot can access them easier rather than trying out to outreach these points, which are near the singularity zone of the robot. Another point to mention is obviously because it could outreach more points, maximum 4 points for each. And also, I have already calculated the distance between these two, as we can already measure the maximum radius of the robots, which would be 864 millimeters. Sorry, 864 millimeters, yes. For the distance, it should be the diameter or double of the size for avoiding collision. So I'd rather choose, the 1 and 2 because even the distance between them is higher than this amount, 1.728, which is double space or dimension of the radius or effective range that each robot can have. So no collision can also happen. And this is because I have chosen the maximum radius, which is so important because based on that, if the maximum range doesn't conflict or doesn't lead to collision, it means that even for other z coordinates, for other points which can have different angles for different pose, the radius would be shrink less than this. So I specified or considered the highest zone or highest area that it could outreach. And based on that, I am pretty sure that there is no possibility for any collision between these two areas, 1 and 2. So the justification that they have for why I outreach 4 points, and this is similar to the other one, because it is highly dependent on the effective range that each robot has, which is so important, as we can see in the graph so easily. And also the singularity range, which is important. And also I mentioned that within the different z, we will have different range, but the maximum one would be this. So even for the collision, we can use that. But it all depends on the distribution of the points as well as the effective range that our robot has. So As you can see, these could outreach different points. These are with different coordinates that it could cover either by robot 1 or robot 2 placement or location. But the thing is, um, they could outreach them more. I mean that if the distribution of the points would be different and it would be within or inside the zone, effective range zone that we have, and it wasn't close to the singularity zone based on the limits that we have. For example, end effector must be downwards, and all of these conditions, it would be high probable that we could outreach more points. So I tried to guess other locations as well, but I couldn't outreach more than 4 points. And that's the maximum points that I could reach based on the calculation, based on the solution or inverse kinematic that I applied using this command, solution puma.ikine underline A, but based on T. And T would be different from 1 or 30 until 30. So thank you very much for your consideration.